In today's engineering world, just knowing the theory, it's not enough anymore. We really need graduates who can design for the future, and that means getting sustainability from day one. So in this explainer, we're going to dive into two incredibly powerful tools that are totally reshaping engineering education, turning classrooms into what are basically real-world design labs. So let's just kick things off with a pretty fundamental question. With everything changing so fast, what are the core skills an engineer actually needs to solve tomorrow's problems? Believe me, it's not just about the old school technical basics anymore. It's about having the vision to tackle some really complex challenges head on. And this really gets to the heart of the modern engineer's challenge. The demands on engineers today, they've completely shifted. What used to be a little niche specialty is now, well, it's the baseline. It's the new standard. Yeah, the biggest shift is this. Sustainable design and energy performance are no longer just nice-to-haves. They're not optional extras. They are absolutely essential core competencies. A modern engineer today simply has to understand how their designs affect energy use right from the very beginning. So, how do we build these supercritical skills? Well, the answer really lies in having the right tools for the job. We're going to focus on two key pieces of software that, when you put them together, create this incredible learning platform: Sketchup and Sophia. Let me break down how they work together, because it's pretty cool. Just think of Sketchup as your digital blueprint. It's where you bring your ideas to life and create your intuitive 3D model. Then Sophia comes in and acts like the analytical brain. It takes that exact model and calculates its energy performance. So one builds, the other analyzes. That synergy is just incredibly powerful. Okay, so that's the big idea. But how does this actually play out in a real university curriculum? Let's get specific. Let's look at exactly which courses can be completely transformed by using these tools. So for all you mechanical engineering students and faculty out there, the applications here are immediate. In a course like Computer-Aided Design for Building Systems, students can visualize entire systems in 3D. But it gets even more powerful in a class like air conditioning, where they can analyze real, hard performance numbers. And this is where you see the magic happen with a concept like heat load. Instead of just crunching numbers on paper, students can actually model a building in SketchUp and then use Sophia to simulate the heat load directly. They can instantly test things like different materials or window placements and see right there on the screen the impact on the building's energy needs. All right, now let's switch gears and talk about electrical engineering. In this world, SketchUp is fantastic for helping students plan the physical layout of electrical and signal systems inside a 3D model. But for courses like illumination engineering and energy conservation, that's where Sophia really becomes the star of the show. I mean, this feature right here is a total game changer, especially for a course like illumination engineering. Sophia's daylighting analysis lets students see exactly how natural light moves through their building model. So what does that mean? Well, they can then design an artificial lighting system that works with the natural light, not against it, which can drastically cut down on energy waste. It's practical, it's tangible, and wow, is it impactful. So when you look at this all together, what you're really seeing is a learning pipeline. Students aren't just using these tools for, one-off tasks. They're building a whole comprehensive skill set, moving from system layout to detailed heat and light analysis, and then finally to big picture energy conservation. It's this progressive journey, all using one integrated workflow. But look, this is bigger than just passing a few individual classes. Let's zoom out a bit and see how all these skills really come together for a student's final and most important work. This is what's so crucial. It's how all this training empowers students when they get to their big capstone projects. They're not scrambling to learn some new tool in their final year. They show up with a full skill set, ready to do some seriously advanced research and design, right from day one. So it really creates this awesome, clear journey to innovation. First, students learn and master the tools in their core courses. Then, they apply them to analyze really complex problems. And finally, they're fully equipped to innovate, creating final projects that are genuinely sustainable and efficient, right, by design. Which brings us to our final and honestly our most important points. What is the ultimate outcome of all this? It's all about creating engineers who are truly ready for the future. Because at the end of the day, this is about so much more than just learning a piece of software. Integrating these tools from the very beginning develops a fundamental design mindset. It teaches engineers to think about performance and sustainability from the very first line they draw. It becomes second nature. So the real takeaway is this:
By combining 3D modeling with energy analysis, we're creating a single, powerful, and incredibly valuable skill set. Graduates who have this aren't just mechanical or electrical engineers. They are holistic system designers who are ready for the modern workforce.
And that really just leaves us with one final thought. We have the tools right now to train a whole new generation of engineers who can build a truly sustainable world. So the only question left is your curriculum ready for that future?